Imagine the vast, silent emptiness between the stars, an ocean of cold and dark stretching for light years. For eons, we thought this expanse was empty, but now we know it has its own travelers. On July 1, 2025, astronomers in Chile spotted a faint smudge of light moving against the stars, a ghost that didn't belong. Its path was all wrong, not circling our sun, but on a one-way trip, a cosmic tourist just passing through. Whispers spread. Could this be alien technology? A probe from another civilization? Its trajectory was so unusual, scientists had to consider the possibility. The object was moving too fast, its path too straight, to have come from our solar system. It had come from the interstellar deep. Every telescope turned to study this enigmatic visitor. The object was named 3I/Atlas, the I for interstellar, a title reserved for the rarest celestial guests. It was only the third such object ever detected. As data poured in, wild speculation gave way to consensus. It wasn't a spaceship, but the truth was just as thrilling. 3I/Atlas was a comet. Yet it was a comet unlike any we'd seen, a relic from the birth of another star system, trillions of miles away. This didn't diminish the excitement, it amplified it. An alien craft would tell us about one other intelligence, but an alien comet could reveal the universal processes that build worlds. It was a physical piece of another solar system delivered to our doorstep. What secrets would it reveal about the chemistry and history of its home? And 3I/Atlas is a comet, but calling it just a comet is an understatement. When telescopes first examined it, we expected something utterly alien, exotic materials, a unique fingerprint. Instead, the spectral analysis told a startling story. The dust and ice looked familiar. The building blocks matched those in comets from our own solar system. This suggested that the raw materials for making planets and comets might be universal, a common cosmic recipe. But then, 3I/Atlas surprised us again. The types of materials were familiar, but their proportions were extreme, like a cake with way too much salt. Its chemical makeup didn't fit our models. This wasn't just another dirty snowball. It was a puzzle box. Hubble measured its nucleus at about 2.8 kilometers in radius, normal in size but not in behavior. The real strangeness was its activity. It was putting on a show while still far from the sun, beyond Jupiter. Something was causing it to shed gas and dust at a furious rate, long before a normal comet would stir. The ghost wasn't just passing through, it was screaming. What was fueling this outburst? What made this comet so active so far from the sun? The James Webb Space Telescope found the answer. With its infrared eyes, JWST peered into the comet's coma and analyzed its composition. The result 3I/Atlas was spewing enormous amounts of carbon dioxide gas. For most comets, water ice is the main ingredient. They stay dormant until close to the sun. But 3I/Atlas was different. For every part water ice, it had 8 parts carbon dioxide ice, one of the highest ratios ever recorded. Carbon dioxide ice, or dry ice, is far more volatile than water ice. It turns to gas at -78.5 degrees Celsius, so even the faint sunlight beyond Jupiter was enough to vaporize it. This explained the comet's early, intense activity. 3I/Atlas was running on a different kind of fuel. This discovery is a fundamental clue about its origin. Such a carbon dioxide-rich object likely formed in a very cold, distant region of its home system. Its extreme chemistry is a postcard from a very different planetary nursery. What else could it tell us about its birthplace? The comet's strange activity began even before its discovery. Archival data from NASA's test satellite showed 3I/Atlas was already active in May 2025, over 6 times farther from the sun than Earth. For a typical comet, this region is a deep freeze, but for 3I/Atlas, it was warm enough to awaken its volatile heart. The Sphere-X telescope saw a coma stretching 348,000 kilometers, nearly the distance from Earth to the Moon. As it journeyed inward, its activity intensified. Images from Gemini South in August 2025 showed a growing, dramatic tale. This was a dynamic, evolving world, dismantled by our sun in real time. Unlike comets that have visited the inner solar system before, 3I/Atlas is on its first and only journey. It's brand new, carrying an unaltered chemical record from its birth cloud. We're witnessing a pristine relic from another star system. What can this untouched traveler teach us? The arrival of 3I/Atlas sparked a global campaign of cooperation. Telescopes worldwide and in space united to study this fleeting visitor. Giants like Gemini and Hubble measured its size and composition. JWST revealed its carbon dioxide abundance. Even satellites like TESS and SphereX joined in, mapping its coma and early activity. Data was shared rapidly, fueling a worldwide scientific effort. This collaboration is the future of astronomy, open, international, and driven by wonder. As the comet nears the sun, it will vanish in the glare, but our watch continues. Even as it departs, spacecraft like Juno may catch a final glimpse. Every comet is a time capsule, but 3I/Atlas is a sample from another world. It tells the story of a distant star and its planets, not our own. Imagine finding an Incan artifact in an Egyptian dig. 3I/Atlas is that rare, revolutionary find. Its high carbon dioxide content is a direct clue to its birthplace, colder or chemically different from our own. Perhaps its parent star was unlike our sun, shaping a unique protoplanetary disk. These are the questions that drive planetary science. 3I/Atlas helps us place our solar system in a galactic context. Are we typical or rare? Its familiar ingredients suggest universality, but its extreme chemistry hints at wild diversity. By studying more interstellar travelers, we can build a true picture of cosmic creation. Each one adds a crucial piece to the puzzle. 3I/Atlas is our first real data point from another solar system. What will the next one reveal? For decades, our theories of planet and comet formation were based on a single example, our solar system. 3I/Atlas has shattered that simplicity. Its carbon dioxide-rich composition doesn't fit our models, forcing us to rethink everything. This is the essence of science. A single counterexample pushes us into new territory. Perhaps it formed where the CO2 ice line was different, or in a disk with a unique chemical mix. Its existence proves nature has many ways to build planetary systems. These rare visitors are natural experiments, sent by the universe itself. 3I/Atlas is a messenger from afar, refining our understanding of what's possible in the galaxy. As 3I/Atlas journeys through our solar system, it's more than a curiosity. It's a tangible connection to the cosmos. Unlike distant starlight, this is a physical piece of another system, right here. It traveled for millions of years through the void, ejected from its home by a gravitational nudge. By chance, its path crossed ours, giving us a fleeting chance to study it. This reminds us that solar systems are not isolated. The galaxy is a place of exchange. Even life's building blocks could travel between stars on objects like this, a real mechanism for panspermia. While there's no evidence of life on 3I/Atlas, its journey proves the transport is possible. Studying it is like a conversation. We listen to its story through chemistry and motion. It speaks a universal language, telling us about its birth and journey. It's a silent messenger, revealing the interconnected story of creation. What other secrets might the next visitor bring? The universe is speaking. Are we listening? The discovery of 3I/Atlas is changing our perspective on our place in the universe. For most of history, we saw ourselves as the center, but these interstellar visitors shatter that illusion. They show we're part of a vast, interconnected galactic ecosystem. Each new object is a data point in the story of cosmic diversity. The first, Oumuamua, was rocky. The second, Borisov, was comet-like. Now, 3I/Atlas is something else entirely. This variety hints at immense diversity in planetary systems. If the building blocks are universal, planets are likely common, but their chemistry can vary wildly. Are Earth-like worlds rare or common? 3I/Atlas doesn't answer, but it sharpens the question. This icy wanderer inspires awe and wonder, reminding us how much is left to discover. As it departs, it leaves us with new knowledge and a sense of belonging to something far greater.